Hi, Alex.
I,
Just you and me again.
oh well, nothing wrong with that. Yeah, I was doing redox reactions and I did like the first credit quiz at like midnight, which was a terrible idea.
Well, you have to be careful with those things.
Well, I actually ran into a problem with that one, and I was hoping you can like help me with it.
Well, let's get started at 8. We'll see where people are at. Okay.
Cause I had one of them was like chromium 03. Yeah, chromium.
Well, do you have the actual question in front of you?
I wrote it out.
Well, if
But,
you wanna tell me exactly what it is, I'll.
yeah. So it's CR.
Let me move that. Let me move this a bit. Oops. Okay. Oops. Okay. Let's try this again. Okay. All right. So CR 03.
3 plus I negative 1 charge. 2 CR2 03 plus.
Are you sure it's 03? 07? It'd be probably 07, wouldn't it?
I'm pretty sure it was 03.
03. CR203. Okay. All right. We'll go with that.
Okay. I'm double checking, but I'm like.
It could have been. Okay. I'm looking at it. Yes, it could have been that.
And then plus I2.
Mm-hmm.
And that was it.
Okay.
And I started running into a big problem once we got to charges.
All right. So we know we need a 2 in front of here and a 2 in front of here. You with me so far?
Yeah.
Okay. Now let's have a look at oxygens. Let's see. We've got 6 on this side. We've got 3 on this side. So we had 3 waters. And down here, that's fine for I. Now the hydrogens, we need 6 H pluses over here. And this over here, again, it's fine. As far as electrons go, well, this one's fairly easy. There's only one thing that has charge, and that's the hydrogen. So we need 6 electrons up here. Down here, we need 2 electrons on this side. And that would be it. But this one's actually not that bad, Alex.
Oh, I see. I see my problem. I had the 3H2
Right.
to the left side for the chromium instead of the right side.
Right. Well, okay, that'll change things. Is that all right?
Yeah.
Right.
For the electrons, I like to do like either TR if it's for top right, and then bigger number minus smaller number, and then TL or TR for, and then BL or BR for bottom number, and whatever side has the higher charge.
Right. Yeah, well, that's a good way to do it. That's how I like to do it too. All right. Did anybody have any other questions that they want to ask about any of the material? Anything specific? Oops, sorry. Anybody have anything specific they want to ask about the material?
Can you do one more redox example? That's like the only thing that I'm not 100% confident on.
Well, we're probably better off doing like a test question, don't you think, Georgiana?
Yeah.
Yeah. Rather than one of the other examples. I mean, if you do the test questions, I feel like you can pretty much do anything. These are kind of tough. Okay. So I just started the test here, Georgiana, and so this is just a kind of a random thing. So whatever popped up, and that's what we're doing. Is this one okay for you, Georgiana?
Yeah, this works. Yeah.
Okay, good. Yeah, this is usually what people have the most problems with, I think. XO2 minus. Not sure what that is. All right. Okay, so on the top line, the x's seem to be okay. On the bottom line, we've got 2 y's and 1 y, so we need a 2 in front of this, so that's okay. All right, so we need oxygens. So Georgiana, I'm going to put you on the spot here. How many waters do we need to add to the top one, and which side do they need to go
on? For the top one, you would do 2 waters, and it would be on the right side.
Okay, good. 2 waters on the right side. Okay. Hey Alex, I'm going to ask you this one. How many oxygens, since you had an issue with the last one, how many waters need to be added to the bottom reaction? Which side do they need to go on?
You'd add 3 waters to the bottom left.
Take a look. Look at the 2 here.
Oh, 6.
6. And maybe 6. Yeah, so this is something you've got to be real careful of, Alex.
I'm still waiting.
I know. But I'm still gonna force the issue on that. The hydrogens are fairly easy on this one. Okay. All right. So what I want you all to do here is figure out the number of electrons on both. So I'll give you a couple of minutes to figure out, or a minute. I'd say you just need a minute here to figure out how many electrons need to be added to each reaction, which side those electrons need to go on. In the meantime, I'm just going to go get some water. Back in a second. Okay. Top reaction. What are we getting there?
I got left side, and it's 5 because 4 minus 1 is 3, and then you got -2, so that'd be 5.
Okay, 5 electrons on the left side. That's correct, I think.
And the right side, the left part is neutral from what it looks like. So it'd be bottom right, and since we have a 2 and -2, and then 12 would be 8.
Oh, yeah, the 8 is good on that. Georgiana, how are you going with that?
Yeah, and that makes sense.
Okay.
Me.
All right. Kyle?
We're good.
Okay. All right. So that's the hardest part, I think, Georgiana. I mean, if you get that far, I think you're doing pretty well. Okay. So Georgiana, tell me how many waters we would have and what side they would need to go on.
You would have 6. Well, for the first one, it'd be 8 times 2, so you would have 16 waters on the right side,
Mm-hmm.
and then the bottom would be 30 H2Os on the left side, and then you would cancel them.
Right. So you have 14, right?
Yeah, 14 on the left.
Okay, that's good. All right. What about the H pluses?
You would have 8 times 4, 32 on the left side, and you would have 60 on the right.
Mm-hmm. That's
So
right.
that would be 28 on the right.
All right. Let me give you a bit of a hint here. Oops. Sorry. H plus. When there's no change to the hydrogens in the initial problem, and you can see this here, this doesn't apply to the other kind of example you might see with the Q's in it. But for an example where there's no hydrogens present in the initial equation, the situation will always be that you'll always have the hydrogens balanced at this point. So 14 times 2 is 28, and you'll have 28. So if you get 14H2O, it's kind of a good check because you can look at that and say, oh yes, I need to make sure I do get 28 on the H plus. And if that doesn't happen, then either you've made a mistake with the H plus or you've made a mistake with the H2O. And it's a good check to make sure that you have done that. Now, remember that doesn't apply in the ones where there are hydrogens in the initial problem. Okay. The rest of this is relatively easy at this point because now we've got just to drag everything down. So 8xO2 minus plus 5y2s. And down here we've got 10y/3, 2 minus, and 8x2 minus. Now, I would want to check this and make sure that everything has balance. The x's look okay, 8 and 8 is good. Oxygens, 16 plus 14 is 30. 10 times 3 is 30, so oxygens are okay. Hydrogens, 28, we already got those. And the y's are 10 and 10, so that looks like it's balanced for the elements. Let's look at the charges. We have a total of -8. Yeah, that's a 2. We have a total of -8 on the left. We have 28 minus 20 is 8, minus 16 is -8. So -8 and -8. So that is definitely balanced. And then you can add everything together. 8 and 5 is 13, and 14 is 27, plus 28 would be 55, plus 10 is 65, plus 8 is 73 is what I would get for that. Does anybody have any questions? So Georgiana, how do you feel about that one?
That makes sense.
Okay. Did you want me to see if I could get up another one of the other type with the Q's in it?
Are most of them with the X?
Well,
Y's.
it's about half and half, really.
Oh, okay. Yeah, sure. We could do it with the Q's then.
Okay. Because that's one of, I don't mind doing these because this is what a lot of people do have trouble with. And it's really more a matter of how much care you take while doing it. Because it's not like it's incredibly difficult or anything. But you have to be real careful. Actually, it's the wrong. You have to make, but the good thing about that problem, the one good thing about it, is that you know if it's right or not, because you can check it. And if everything doesn't add up, you know you've made a mistake. You have to go back and fix it. Yeah, there we go. This one here, this one will do. Now remember what I had said earlier about the hydrogens and in the water and the H pluses balancing.
Yeah.
This is not going to happen in this case. I can guarantee it because we have hydrogens here, we have hydrogens here. I know we have the same number of hydrogens, but that doesn't matter. If you've got hydrogens in the initial equation, we know that the waters and the H pluses will not balance. Okay, and QH6O and QH6O2. Okay. So we know we need a 2 in front of the X. And that would mean down here we can see the Q's are okay. So we need 6 waters on this side. And on the bottom one, we need, how many waters do we need on the bottom one? You wait, tell me.
I count 1.
1. And which side did it have to go on?
The reactant side.
Right, like that. There we go. See, there was already 1 here, and there's 2 on this side, so we need 1 to balance it out. Now on the top one, as far as hydrogens go, we need 12 H pluses. And on the bottom one, let's see, so we've got 2
It looks
6s.
like you only need 2 on the right side.
That's right. Now the electrons are easy on the bottom one, it's just 2 electrons. Now what about the top? How many do we need on the top?
Nine.
No, I don't think so. I don't think 9 is right.
Oh no.
Would it be 5?
I don't think 5's right either.
It would be 1.
No,
7.
7. It's 7.
7.
Yeah. So 12 minus 4 is 8.
Oh, the 12. I didn't include the 12.
Yeah, 12 minus 4 is 8. And then 1. The difference between 8 and 1 is 7. And that goes on this side. Yeah, so this is something you have to be really, really careful of, I think. Anybody got any questions? Okay. All right, let's talk water first. Oh, hang on. Let's multiply them first. So it has to be multiplied by 2, and the other one has to be multiplied by 7. Okay. All right, how many waters do we need, and which side do they need to go on?
Let's see, that's 12 H2O, that's 7 H2O, so that's going to be 5 H2O right side.
sounds right to me. And remember, the H pluses won't balance for this one. So what are we getting for the H pluses, and which side are they going on?
It looks like we have 10 H pluses on left side because
I guess it does balance. It's a bit of a miracle here, I suppose. All right. Okay. Doesn't necessarily have to balance up for that. It looks like it is 10, doesn't it?
well, the only other H is from like the Q, but that's like already
But
balanced.
those actually already balance out. So maybe if the hydrogens already balance out on the Q, then maybe the waters will balance. I suppose that's probably a better generalization to make. Okay. Well, it's good to know. All right. So 10. All right. Fair enough. And then the rest of it's fairly easy because it's just going to be just dragging down what's here. What else have we got? 7. And 7. And 2x2. Okay. And again, it's good to check it and make sure that everything's okay here. The x's are okay. 4 and 4 is fine. The q's are fine. 7 and 7. The hydrogens, 42, 52 on the side. 10 plus 42, 52. So that's okay as well. Oxygens, 7 plus 12, 19, 5 plus 14, 19. So that's okay. Hydrogens 10 and, well, 10 and, no, I've already done hydrogens. We're okay. All right. So yeah, it looks like everything's good there. Now the charges, -8 plus 10 is 2, and on the other side, 2 times 1 is 2. So everything balances there. So I know that's correct. And then adding them all up, 4 and 7 is 11, and 10 is 21, and 5 is 26, and 7 is 33, and 2 is 35. Does anybody have any questions? All right. Does anybody have any other questions that they want to ask about any of the material?
Yeah, my question about the test was, what is like the essay part of the?
Oh, okay, yeah, that's a good. I'm glad you brought that up. Okay, let's take a look. I have mentioned it before, and it is in the syllabus as well. Let's go take a look at the syllabus and see how it fits into the test grade here. I haven't received any yet, which is kind of a little bit concerning to me.
I'll probably start working on today.
Oh, okay.
Yeah, I finished it. I'm just double checking it now.
Oh, all right. Okay. All right. So test 3, the complete score for test 3 here we go, is 70% for the test. The essays are worth 20%, and then there's a units quiz, and then there's any test 3 extra credit that goes on top of that. So the units quiz is not done under honor lock. It's still worth 10%, but you can do it as many times as you need to. I think most people should get 10% on that eventually. That's what I would say, yeah, as long as they try it. Now let's go back to the essay questions. The requirements for that. Did I send out I thought I sent out an email about this too, didn't I? The essay questions. Did I at some point or not?
I don't
remember
think
one.
so.
You don't remember?
But I can't remember, so.
Yeah, I might
No,
have. Probably not. Now, if you don't remember, I probably didn't. But I have mentioned it before in class. But yeah, as you can see, not a lot of people attend class. Some people watch these later, but a lot of people don't. So I don't know. So these are the topics, and you need to do all 7 topics. They're just 50-word essays, but you need to include a reaction that relates to what you're writing in the essays. These are all redox processes, so you need 2 half reactions and a full reaction. You can find any information by using your textbook or on the internet. And if you can just look these up in the index, of your textbook if you want to, or you can just put them. Lots of stuff's been written about all of this, in lots of different places. Now, this is expected before the test. And also, if you look here, if you look in the Dropbox, I'm going to ask you to include a household object with the picture. I know that sounds weird, but that's how it looks. I've also got a sample page of one of them, so this gives you an idea of what I'm expecting, at least for 2 of them. All right. So Alex, is that okay?
I've just quick to clarify. So you just want an explanation basically of what process we're describing, and then some sort of chemical formula representation of that involving the half reactions and the full reaction.
Yeah, that sounds about right. Now I give you a lot of latitude about what you write. Okay, there are lots of, because there's lots of different things you can write. So as long as it's pertinent, and then you'll be okay. But also make sure. Go on.
I have like a textbook that I bought for Intro to Chem, which is like, so I have about half of these topics are in the electrochemistry section, and I think about the other half I'll probably have to go looking around or.
Yeah, you would probably need a more advanced textbook to, if you're looking for a textbook to have those other topics in there.
Yeah.
But there's plenty of information on the internet about all of this stuff.
Do you care about citing or anything or telling me where we got it from? Okay, cool.
No, right. not interested.
Good.
But I'm definitely interested in all of these requirements being met. So I'm not asking you for much. 50 words really isn't very much to write.
I'm just gonna warn you now. My handwriting is atrocious.
Well, that's what it is. So you'll notice this person has signed across down. Let's go back to the Dropbox here. Yeah, I think what I might do is after class, I'll send out an email and tell people to watch this part of the Zoom video if they're confused about what they need to do. I think a lot of people don't even realize they have to do it. Well, because they didn't hear me talk about it when I talked about it in class, or they haven't read the syllabus or whatever. So they're going to get a bit of a nasty shock that they have to do this.
To be honest, I thought it was like some kind of written portion during test 3.
It is actually. It is when I do it in class, or at least it has been in the past. Now, what am I doing? That's right, I'm looking at the Dropbox. Okay, so there's the Dropbox, and these are the conditions. It's the same thing. So you'll have to include a real fork in each picture. Okay, a fork. And it has to be, all these have to be combined into a single PDF or doc file, docx file. Now with the document, it's not very difficult to do it for Word. You just take the pictures and you just insert them into a Word document. That'll work for me, that's fine. Some people like to do it as a PDF, that's okay as well. Make sure you do include a fork with each picture though. I know you might think that's a bit weird. You think I've gone crazy, but I do have reasons for that. Anybody know why I've asked you to include a fork? Any ideas? What do you think it's?
Just so you know, it's from this class time. Because next time you could ask them to include like a spoon or something.
Oh, well, maybe I would, Georgiana, yes, but it might not be. It might not be a spoon. It might be something else. That's right. Yes, I'd probably try it for something that wasn't a utensil. But yes, that would be the idea, and it is just so that people can't share this with other people and use it in a future class, because you could do that. You could send it to somebody and say, well, you don't have to do this. But I know you could still send it to somebody. At least they'd have to still write it out, though. All right. Does anybody have any questions? All right. So don't forget about the units quiz as well, the test 3 units quiz. And there's a video here about how to do matching problems in my courses. And that might be useful to you if you're not really that familiar with matching problems and how to set them out. I'll show you what the units quiz looks like here. So yeah, it looks like this. And you'll notice there's this unused answer. So you do have to, for anything you don't choose as an answer, you have to put it in the answers here. So for this one, delta H has the units here. Kilojoules per mole. So that'd be 1. And then 2 would be Kelvin. Delta S is joules per mole per Kelvin. So that'd be number 3. And 4 and 5, that would be the joule kilojoule conversion. So let's see, 1 kilojoule for number 4 and 1,000 joules for number 5. And then the rest of these have to be unused. So it'd be 6 and 6. And that's how you would do it. This isn't that difficult. It's just, I know that one of the shortcomings of testing the way I do is that I don't get to grade your dimensional analysis or your understanding of units. And I figure, well, this is at least a way that I can get I can capture some of that. It's not incredibly difficult, but you'll still have to do it. Okay. Does anybody have any questions? Okay, I'll try to remember after class to send out an email to tell people to watch this Zoom class so that they can get some ideas about the essay. And just to remind people they have to do it. So remember, the test is due a week from today. You don't have to do it on Tuesday of next week, but you have to do it before Tuesday of next week. I'd recommend doing it early. So try and get as much practice as you can in on the ungraded copy, and then you should be good. Remember that you are required to use the honor lock calculator, so practice with the honor lock calculator. All right, does anybody have any questions? Any other questions that they want to ask? Thanks, Alex, for that.
No, I guess we could do like Gibbs string entities since it's been a while.
Yeah, well, I was just going to start from the beginning of the test and just go through it. So you can see you have the honor lock calculator here. You can right click on it. and open in a new, I would open in a new window, and then I'd have it off to the side here is what I would do. That would be how I'd treat it, and then I can use it. Okay. All right, enthalpy. I'm not going to do the whole problem here, just to show exactly what we would do. So the enthalpy is going to be based on the heat of formation. And let's see. So this would be.
Wouldn't that be the SO values?
No, that's entropy.
So it's HF.
Yeah. So delta H is going to be the sum of the heats of formations of the products minus the sum of the heats of formations of the reactants. And then of course we have to take into account the stoichiometry as well. So I like to put them in square brackets. So 2 times 59.40 plus 91.81, since it's just 1 times. Oops. Square brackets. And then minus, let's see, products. Minus reactants, so 4 times A plus 2 times B plus C Now you can do these separately, and that's okay, but don't round anything to significant figures until the very end, because this is going to be based on the number of places past the decimal. Conveniently, all of these have just one place past the decimal. So the answer is going to have 2 places past the decimal. So the answer will have 2 places past the decimal as well. So I'm not going to do the math on that, but that's how you would do it. Does anybody have any questions? So the other one, now Alex, this is entropy, and delta S is the sum of the entropies of the products minus the sum of the entropies of the reactants. So same kind of setup, and this one's going to be 4 times 196.41 plus 4 times 121.46. And that's minus, and it's just one of each of these by the looks of things. Minus 60.33 plus 62.23 plus 76.8. 0. So I usually find that the entropies are a little bit easier because they tend to be positive values. That's the way I've set them up. The delta HF values, delta H ethanol values can be typically negative or positive. More likely negative than positive, but sometimes they're positive. But the S0 values are typically positive. That makes the calculation just a tad bit easier, I think. Does anybody have any questions about number 2? Okay. Okay, number 3 is more a combination of what we just did. But when you get to the Gibbs free energy, it's going to be delta G equals delta H minus T delta S. And once you get a delta H value, it's going to be in kilojoules per mole. the temperature here is given to you 25 degrees, so it's definitely going to be 298 K times the delta S naught, which is going to be joules per mole per Kelvin, which necessitates a conversion. I showed you this in the units quiz earlier, into kilojoules. So you can see that by doing that, what we end up with is something kilojoules per mole minus, again, something kilojoules per mole. I don't really want to go through and do the math on that, because we just did the math on the delta H and delta S, and then you're just going to apply that and to just be wary of the units and understand why we have to do that conversion in the process. Does anybody have any questions about delta G? So Alex, you had asked specifically about Gibbs free energy. Is there a question you have about that?
I just wanted to see how it was done. It's been a while.
Are you okay with what I just did?
Yeah.
Okay. The next one is K, which in turn is again based on the delta G. So this is something you have to be a little bit careful of. So delta G is equal to negative RT ln of K. Now this is actually looking for PK, so that's important too. So if we want to isolate K, and you might be wondering, well, how do you know the equation? I actually give it to you, I think up here. There it is. See, delta G is negative RT ln of K. Sorry. If you want to isolate K, you can do this. You can do ln of K is equal to negative delta G over RT. And then K would equal E to the power of negative delta G over RT. Now for delta G will be in kilojoules per mole. So what I like to do is I like to handle this separately. So it'd be some sort of negative of whatever you're getting for delta G. So understand that if delta G was negative, this is going to make it, putting the negative in front of that will make it positive, but it will be in kilojoules per mole, the delta G value. So just let's do this, delta G over RT. Now the R is given to you in the problem. And this is why it's so important to recognize the units here. And you'll see that it's times K, which is again going to be 298. But we've got joules here and kilojoules here. So I have to multiply, again, do a joule to kilojoule conversion, multiply by 1 kilojoule over 1,000 joules on the bottom there. And then I have to do E to the power of whatever I get there. And that will give me my K value. Now to get PK,
Isn't that negative log of K?
yeah, so this will give K. Our PK is the negative log to base 10, that's log of K. So this is a little bit confusing because what you have to do is you have to use E to the power of, which is the inverse natural log, and then to get PK, you have to take the log. Now you might be saying, well, how would you know to do that? Well, if you look at the video, remember I have videos for all of these. I go through that. I do. I go through that completely. Does anybody have any questions? The reason I ask for pK is so that you end up with a number that you can easily put into the box, right? Because it's always going to be something that is in the, well, units, tens, yeah, units or tens. It will be something in that range. It could be positive or negative, just be aware of that. And remember with pK, you're taking the negative log. So that's important as well. Now, you might be saying, what if I make a mistake and I put a positive instead of a negative? Well, I've given you plenty of time here, and down the bottom of the test you take, there's actually a space for you to put your work. So I'd recommend putting your work down there. A lot of people don't like doing it. They think it's a pain, and they think they should just be able to take a picture of their work and send it to me. But I can't allow that because it's too easy for people to see where they've gone wrong on a problem and then fabricate some kind of working after the fact. That's why I require that it be that it actually be copied into the test or not copied into the test, but actually written into the test. And that's why I give you extra time so that you can allow yourself to do that. Okay, does anybody have any questions? Okay, so for this one here, determine the difference in relevant particles but allow for determination of delta S. And again, I have a video about this very specific problem that we're seeing here. You can see the answers. It's multiple choice, but it goes from -8 up to +8 with a positive number greater than 9 or a negative number less than 9, -9. So for this one, what you're doing is you're trying to determine based on knowledge of delta S. And one of the things we talked about was the effect of different kinds of particles on entropy. And what we know is that for delta S, we know that gases, or actually just for S really, gases are greater than aqueous ions, is greater than pure liquids, is greater than solids. So the actual states of these things are important here. And the only relevant particles are the ones that have the most contribution to the entropy. So in this instance, we're only interested in the aqueous particles. So for this one, we're not interested in the solid, and that's the CaCO3. We're only interested in the aqueous particles. So when we're looking at 2NaCl, what we do is we draw a picture of what NaCl looks like. So that's what we have on the reactant side, and it's a total of 4 particles, aqueous particles. On the product side, we've got 1 Na2CO3. This would be the approach I would take. The charges aren't incredibly important here. It's just being able to split them apart. That's 3. And CaCl2, again, it's just one particle there. One box, sorry. CaCl2, that's 3. So the difference there is we have a total of 6 aqueous particles here and a total of 4 particles here. So it's always, delta S is always products minus reactants. So it's going to be 2. 6 minus 4 is 2. Does anybody have any questions? Now, just as a as a rule of thumb here, the side that has the solid will always have less entropy than the side that doesn't have the solid. I think that's a good rule of thumb to realize. And if the solid is on the reactant side, it means there's an increase in entropy. So you're always looking for a positive value in that instance. If the solid is on the product side, that represents a decrease in entropy, and I'd be expecting a negative value. Does anybody have any questions about number 5? Anything at all? And remember, I do have videos for all these problems as well, if you get caught up in the wording or whatever. Okay, number 6. So we're applying the delta G equation here. And again, I would, once you figure out what delta S is, it has no effect on delta H. That's the other thing I want you to realize. They're two separate things. So here I know what delta H is. Delta H is exothermic, which makes it negative automatically. Now delta S here, I can look at it, I can tell. You see how it's going from 2 aqueouses to a solid over here. That would tell me that entropy is decreasing, so I automatically know delta S is negative. So if the solid is on the right side, it's going to be a positive value for delta S. If solid is on the left side, it's always going to be negative, because it means entropy is decreasing going from the reactants to the products. And if you remember the equation for delta S, it is the sum of S naught of the products minus the sum of S naught of the reactants. And if this is in this case, this is a small number minus a big number, which brings it to being a negative value. Does anybody have any questions? Now, once we've done that, then we can apply our equation here. And we know that delta H is negative. And another rule of thumb I can give you here is that if the signs are the same for the delta H and delta S, then there is going to be variation with temperature. But if the signs are different, then there's going to be no variation with temperature. In this case, their signs are the same, so I'm expecting variation with temperature. So what I know is this: at low temperature, and what I kind of do is I think, well, okay, temperature low, that would be 0. Let's say it's 0. That means that delta G would be negative, which would make the reaction spontaneous at low temperature. At high temperature, I could imagine that this is a negative minus a negative, that this value that I'm circling here could be big enough at some point in order to surpass the negative value for the delta H, and it could make it positive. So at high temperature, delta G can be positive, which would make the reaction non-spontaneous. So it really should be that easy. You should be able to immediately tell, without any real drama. You should be able to tell immediately what the signs of delta H and delta S are, and then to apply them to the delta G equation. Does anybody have any questions about number 6?
Yeah, how did you determine small minus big again?
But what I did was I looked at the equation, and I looked for where the solid is. Now you could also do some math here yourself, Georgiana. You could count up the actual particles that are relevant here, just like we did in the previous problem.
Yeah.
So this would be 2 times 2 is 4 plus 3 is 7, 7 aqueous particles on the reactant side, and on the product side, ignore the solid, and you can see we've got 4. So it goes from 7 to 4. So 4 minus 7 would be -3, which would make delta S negative as well. But just from a more intuitive standpoint, it's just about noticing how many aqueous particles you expect to see on each side, knowing the solid won't contribute to that.
Okay, so you'll never include the solid typically?
Well, no, you won't, because the solid isn't relevant to entropy if there's aqueous particles present.
Oh, okay, that makes sense. Okay.
And that was from what I had said earlier about, you know, what matters for entropy. You know, with the gases, the aqueous ions, and the solid, etc. Does anybody else have any questions? Anybody have any questions?
When the signs are the same but they're both positive, it acts like opposite, right? So at low temperatures, delta G becomes increasing, and then at high temperatures, delta G is decreasing, right?
Can you repeat that, Kyle? The question.
I'm sorry. Yeah. When the signs for delta H and delta S are both the same, yet they are both positive. So
yes, then it'll be the opposite. Yeah.
Right.
Yeah, it'll be the opposite. That's exactly right. So if they're both positive, yes. At high temperature, delta G would be positive and non-spontaneous. At high temperature, delta G would be negative and non-spontaneous. That's correct. All right, any other questions? Okay. All right, let's take a look at the non-standard cells in the Nernst equation. I think we might call it a day after this. Again, I do have a video that goes through this. I say in the question the reduction potential for X1 plus is 0.58 volts. Now, what that means to you is that X plus 1 electron gives X, and that voltage is 0.58 volts. Now, I know it's set up this way because it has to be set up as a reduction, which means the electrons have to be on the reactant side. And there's always the same number of electrons added as you have the charge. So it's 1 plus and it's just 1 electron. And that would give X solid. Now you'll notice that that's a reduction, but in the actual equation itself, you'll see it's set up. This is the anode. So that means we have to flip it. So I know immediately that that's what I'll have to do. You always have to flip whatever's on the left side because that's the convention of a cell diagram. And that makes that negative 0.58 volts. The other equation, MnO4 minus Mn2 plus and H plus. So I need to pick out the right equation here. And I can see it here. This is MnO4 minus, there's H plus, and there's Mn2 plus there. So that is the correct equation. And since it's a reduction already, I just leave it as a reduction. MnO4 minus plus H plus. Plus 5 electrons. So you do have to pick whichever, there's 2 reactions you're given here. It'll be one of those. You have to pick the right one, obviously. Mn2 plus what have we got here? 4H2O. Okay. And that's positive 1.51 volts. Now I know to balance this, I'm going to have to multiply the top one by 5, so the electrons cancel. And my final reaction here, which is going to be important, is going to be 5x plus, I don't multiply this at all, so just leave it the same. Let's see. And yeah, 4H2O. And I add these two together. Let's see, that'd be 0.93, I think. Now this could be a negative value, so you need to be aware of that. So positive 0.93 volts is what I get. Does anybody have any questions? Now remember, when you multiply the reaction, you don't multiply the voltage. If you flip the reaction, you do flip the voltage. That's what we did in the first step. Then we apply the Nernst equation. So we have to find Q here. And Q is going to be reactants, products over reactants. But the only thing we're interested in is whatever has a concentration next to it. And the things like solids and water are not included in the Q expression. So I know it's going to be Mn2 plus and X plus to the 5th. And then you've got, it's over MnO4 minus and H plus to the 8th. And then we can just plug in what we're given here is 2.16 times X plus, that's 0.60 to the 5th. Now we're not really interested in units here because Q doesn't have units, or doesn't need to have units. 0.16 on the bottom times 0.23 to the 8th on the bottom here of the H plus. All right, that's going to give us a value for Q. And then we apply the Nernst equation. And also the N value here will be the number of electrons transferred in the balanced equation, which happens to be 5. So we know that 5 electrons will be here, 5 electrons are down here. So whatever that happens to be, sometimes you have to multiply both of these together. I mean, you have to multiply both, and that electron will come out to be different. So that's something you have to be aware of. Then it's just a matter of just applying that equation, and that should give you the voltage. I really should put the volts in here as well as part of the unit. Does anybody have any questions? All right. Okay, so you got some stuff to work on. I'll send an email directly after class about the essays. Make sure that people are on the right track with that. And I think it's, let me see when it's due. I just want to make sure when those essays are due. So whatever it says on Dropbox is when they're due. No, it looks like they're due, okay, the night before the test. All right. So test is, no, it looks like, no, I'm lying here. That's the November 10th. That's the night of the test.
Yeah.
Okay? It's the night of the test. Yeah, not the night before, the night of the test. Now all the extra credit is due November 9th. Yeah, so that's right. Yeah, but the essay is due on the day of the test. That's what some people do. Some people do the test and then they do the essays after that. That's okay too. But you know, if you're going to do that, you've got to make sure your time management is pretty well set up for that. I'd recommend doing the essays first, getting them out of the way. They're a bit of a pain. That's what I would do. All right. Does anybody have any questions? Anybody have any questions? Okay, well, we'll leave it there for today. Thanks for coming, and we'll do a little bit more review on Thursday. So do some practice, get some questions, have some. I'll do a couple more of those redocs as well on Thursday.
Yeah.
But the main thing you can do with those is just practice. All right. Any questions? Any other questions?
You good?
Okay.
I'm good.
I'll
Have a
see
good
you.
day,
All right.
Professor. See you on
Okay.
Thursday.
Yep. See you on Thursday. Thanks for coming, guys.
Thank you.
No, he's gone. All right.